Hello everyone. Today we'll be discussing the F distributions, which presented by me and my friend Abhishek. Let's dive into the topic. Let's start it from introduction. What is F distributions? The F distribution is the continuous probability distribution, which play a crucial role in a hypothesis testing, particularly when we are comparing two sample variants. It's frequently used in statistical models such as ANOVA, which means analysis of variance, and regression analysis. Essentially, the F distribution helps us answer questions like, are the variance between different groups or samples significantly different? This is especially useful when you are working with more than two or groups and want to analyze the difference in their spread or variability. Throughout this presentation, we will explore how the F distributions functions and its characteristics. Next is key characteristics of F distribution. The F distribution has some unique characteristics. First of all, it is a right skewed, meaning that most of the values are concentrated on the left and the tail extend to the right. However, as the degrees of freedoms increase, the distribution becomes less skewed and more symmetrical. This breakdown is two main parameters. First is D1, which means numerator degrees of freedoms, which reflect the variability between the group being compared. This is called between group variability. Next is D2, denominators degrees of freedoms, represent the variability within each group known as within a group variabilities. These parameters say the F distributions are essential for calculating of F statistic, which we will cover next. F distribution formula. F statistic is computed as ratio of two independent chi-square distribution is divided by their respective degrees of freedoms in formula, where x2 to 1 and x2 to 2 are independent chi-square variable. The degrees of freedoms in numerator and denominator are crucial in shaping the distribution. Now here is the key ideas. If the F statistic is large, it suggests that there is a strong deviations from the null hypothesis, meaning the group variance are likely not equal. A small F statistic means there is little evidence to suggest the variants are different. We use this concept to test hypotheses in a statistical model, especially when we want to determine whether different groups or treatment have similar level of variance.
Next, let's discuss the probability density function or PDF for the F distribution. The PDF describes the likelihood of obtaining different values of F statistic based on the degrees of freedom. It provides a visual representation of how the F statistic values are distributed. The formula for the PDF includes the beta function, which helps to account for the shape of distribution. Here is the formula for PDF, where m by n whole to the power m by 2 multiplied by x power m by 2 minus 1 divided by b m by 2 n by 2 multiplied by 1 plus m by n x whole to the power m plus n by 2, where b is beta function, m and n are degrees of freedom. The PDF shows that the relative likelihood for each values of f statistic given the degrees of freedom. Now let's move on to cumulative distribution function or CDF. The CDF provides the cumulative probability that the F statistic will be less than or equal to a specific value. It is particularly useful in hypothesis testing because it allows us to determine p-values, which are essential for making decisions about our null hypothesis. Here is the formula for CDF, where I bracket open d1 into x by d1 into x plus d2, comma d1 by 2, comma d2 by 2, where the meaning of I is regularized incomplete beta function and d1 is degrees of freedom for numerator. Accordingly, d2 means degrees of freedom for denominator. It is used to compute probability in hypothesis testing such as determining the p-values.
Let's now look at the some of the core properties of F distribution. Non-negativity, relation to chi-square distribution, degrees of freedoms, and last in mean and variance. Non-negativity. The F distribution can never have a negative values. This makes sense because it's based on the ratio square terms and its square are always positive of 0. Relationship to chi-square distribution. As we mentioned earlier, the F distribution is derived from the chi-square distribution. It represents the ratio of two chi-square variables. Next is degrees of freedoms. These degrees of freedoms, numerator and denominator, defines the shape of the F distributions and play vital role in its calculations. So last is mean and variance. Mean of the F distribution is only defined when d2 is greater than 2. This is because for the smaller values of d2, the formula become undefined division by 0. As the denominator's degrees of freedoms, d2, increase, the mean of the F distribution approaches 1. This makes sense because as the sample sizes get larger with increased d2, the variance between and within the group tend to be more similar because the F ratio to the approach 1. And the variance is only defined when d2 is greater than 4. This is a stricter conditions than for mean, and it reflects how sensitive the distribution is for small sample sizes. And next is hypothesis testings using F distributions. One of the most common uses of the F distribution is in hypothesis testing, especially in tests like F test and or ANOVA. Here how it's work. Propose of F test, setting of the hypothesis test statistic, critical values and decision rule step in conducting the F test. Purpose of the F test. The main goal of the F test is to compare the variance of the two or more groups. It helps us determine if there is a statistically significant difference between them. And setting of the hypothesis. The null hypothesis states that the variants are equal. The alternative hypothesis suggests that the variants are not equal. And test status, the F statistic. We compute the F statistics, which is the ratio of the variance between the group to the variance within the groups. And the fourth one is critical value and decision rule. We compare the calculated of statistic to our critical values for the F distribution table. If the F statistic is larger than the critical values, we reject the null hypothesis. And fifth one is step in the conducting the F test. First, we calculate the F statistic, then we compare it to the critical values from the F tables. Based on this, we decided or not to reject the hypothesis. And a relationship between chi-square and F distributions. To better understand the F distribution, it is important to note its relationship with the chi-square distribution. The chi-square distribution is formed by assuming the square of independent standard normal variables. It is often used in a statistical test involving goodness of fit, and independence. The F distributions is based on the ratio of two independent chi-square variables, each divided by their degrees of freedoms. So in short, the F distributions builds on the properties of the chi-square distribution to enable variance comparisons, making it essential tools for hypothesis testing.
Now, let's discuss about F distribution table or F table. Here is the picture of F table in the right side of the slide. Now, when performing an F test, we often refer to the distribution table. This table provides critical values based on the degrees of freedom for both the numerator and denominator. It is essential for determining whether to reject the null hypothesis If our calculated F statistic exceeds the critical value found in the table, we reject null hypothesis. These tables are crucial tools in both ANOVA and regression analysis, helps to ascertain statistical significance. Now let's move towards our next slide. The F distribution offers several advantages where effective for various comparison, where it is especially designed to compare variance, making it a reliable choice for such analysis. Second one is utility in ANOVA. The F distribution is a foundational element of ANOVA widely used in research. Our third advantages of F distribution is model significance testing. It's instrumental in assessing the significance of a statistical model. Widely applicable is also our next advantages. The F distribution is relevant across various fields, from scientific research to quality control in manufacturing. There are some disadvantages to the F distribution. Skewed distribution. The F distribution is skewed, which can make interpretation difficult, especially for small sample size. Secondly, normality assumption. It assumes that the data follow a normal distribution, which may not always be the case in real world data. Third point is sensitivity to outliers. The F distribution is sensitive to outliers, meaning that even the few extreme values can significantly impact the test result. And our last disadvantage is limited use. Its use is somewhat limited to specific types of statistical tests, particularly those that compares variances. Now, let's look at some practical case studies where the F distribution is used. In education, ANOVA can be applied to compare the effectiveness to different teaching methods. And in finance, we use various tests to evaluate portfolio performance. In manufacturing, the F distribution helps test product quality across production line. We can also use this in medicine. We can compare drug effectiveness across different patient groups. In agriculture, ANOVA helps us to analyze crop yields under different conditions. In marketing, we can test the impact of ad campaign across various regions. Finally, in environmental science, the F distribution helps evaluate the effect of policies on pollution levels. This example shows the broad applicability of the F distribution in real world scenarios. Now, let's move toward the conclusion. To conclude, the F distribution is vital tool in hypothesis testing, especially when we need to compare the variances of two or more groups. Its application in tests like ANOVA and regression analysis makes it a core component of many statistical methods. Understanding the F distribution allows us to make more informed decisions about whether observed difference in data and statistically significant. Thank you for your attention, and we hope this presentation has helped clarify the importance of the F distribution in statistical analysis.